So what we've done so far, right, is we've started with this very, very simple setup with you and Wilma, and we've come to some conclusions about, in some sense, what ought to happen, right? Which of these possibilities on the contract curve is the best one? Is it something that we can answer without knowing how we feel about you and how we feel about Wilma? But we know that if you don't end up somewhere on the contract curve, you guys are doing something wrong, right? You're leaving money on the table. You're missing an opportunity to make everyone happier than you were before. So this is our starting point, right? This is our theoretical beginning. The next thing I want to do is to talk a little bit about, well, if we knew something about your preferences and knew something about Wilma's preferences, right? If we weren't just drawing pictures here, how would we manage to calculate this contract curve, right? How could we find all of the possibilities where there's no way to make both you and Wilma better off? Think about this, make this a little bit concrete. Let's give you and Wilma some utility functions. And to start out with, let's make things very, very simple. Let's say that you and Wilma both have Cobb-Douglas preferences. And let's say that you guys actually have identical Cobb-Douglas preferences. So we'll say that your utility, UI of, Gatorade's word on, GY and BY, right, your Gatorade, your Beefroni, is just going to be something like ln of BY plus 2 ln of GY. And we'll say that equivalently, Wilma's utility is going to be exactly the same, except that she's W, right? GW, BW is going to be ln of BW plus 2 ln of GW. Sound good? And our goal is going to be to figure out what the contract curve is going to be, right? Find an equation for our contract curve. So in order to do this, let's look at the contract curve and think about what has to be true if we're on it, right? What makes it so that this spot here is on the contract curve, whereas this spot here is not on the contract curve. And the key point here, right, is that we're on the contract curve when our two indifference curves just barely touch each other, right? Touch in one spot and don't otherwise overlap, so that there's nothing that's better for both of you. And as we've been talking about through this whole semester, right, geometrically, what it means that our indifference curves just barely touch and then bounce away from each other when we have curving indifference curves like this, is that at this point, the slope of your indifference curve has to equal the slope of her indifference curve, right? This is why the indifference curves don't cross. So it has to be the case that Wilma's MRS is equal to your MRS, right? Right? This has to be true in order for you guys to not have possibilities of making a beneficial exchange, right? We can see this geometrically. So we're going to be on the contract curve. If MRS Y equals MRS W, right? This makes sense? Now there's one other thing that has to be true that makes this on the contract curve, which is equivalent to satisfying your budget constraint. And that's that collectively, you guys need to be consuming everything, right? This point that we've got here is a point where everything you have, right? Let's say that you have 200, everything you don't have, Wilma has. Everything you don't have in Gatorade, Wilma has, right? So the other condition is going to have to be that GY plus GW, right? The total Gatorade is going to equal all the Gatorade that exists, right? And then the same is true for Beefroni, right? BY plus BW also has to equal all the Beefroni that exists, right? Which is going to be 700 plus 300 equals 1,000. This make sense? If we're satisfying these three conditions, then we've got to be on our contract curve. So let's do it. Let's do some math. So your MRS is of course going to be the ratio of your partial derivatives, right? du dgy over du dby, which is going to be 2 over gy divided by 1 over by is going to be 2by over gy. Okay? And her MRS is of course going to be the same thing because you guys have the same preferences, right? MRS W, GW, BW, du dGW over du dPW equals 2 over GW over 1 over BW, which is going to be 2BW over GW. Good? So the first thing we're going to want to do here is set these two things equal to each other, right? So we'll say 2by over gy has to equal 2bw over gw, right, in order to be at our contract curve. And this is great, but by itself this isn't all that helpful for us, right, because we have four variables here. So what are we going to want to do? Well, we'll also use our equations here, because we'll say once we knew how much beefaroni you have and how much Gatorade you have, we must know how much beefaroni and how much Gatorade she has, right? So we're going to also say that BW is going to equal 500 minus GW. I'm sorry, what am I saying? BW, let's back up. Sorry, GW equals 500 minus GY, right? And we're going to be able to say that BW, right, her beefaroni, has to equal 500 minus your beefaroni. This makes sense? What we're saying here is everything you don't consume, she's going to consume. So now we can say, right, we can plug these values in here, and we can say, and now I'm going to just switch to all black. So we'll say 2by over gy equals 2 times 500 minus by over, this should be 1,000, over 1,000 minus gy. Right, the 2's are going to cancel. So we can cross multiply here. And what we'll get is, sorry, move things over here. Also, it should be right 1,000 minus by, 500 minus gy. Sorry about that. So when we cross multiply, we'll get by times 500 minus gy equals gy times 1,000 minus by. What are we going to try to do from here? What's our objective here? When are we going to be finished solving for our contract curve? Well, if we think about what this contract curve is, right, it's an equation that's going to relate gy, your Gatorade, to by, right, your beefaroni. So what we want to know is essentially, if I have a certain amount of Gatorade, how much beefaroni must I have if there are no gains to trade, right, if I'm on my contract curve? So our ultimate goal should be to find an equation of by in terms of gy. So what do we do from here? Well, we can distribute, right? So we can say 500 by minus by times gy equals 1,000 gy minus by times gy. From here, right, because I'm going to want to get by by itself, I'll pull all the by terms together, right? So I'll say 500 by minus by gy plus by gy, in this case they cancel out, equals 1,000 gy. So I can say that by is going to have to equal 1,000 over 500 times gy, right? In other words, by is going to equal 2 times gy. So what we're going to say here for this particular example is that our contract curve is just all the positions where you have twice as much beefaroni as you have Gatorade, which in this context, because there's twice as much beefaroni that exists in the world, is saying essentially that you have to have exactly half of all the stuff. If you had more than half of all the stuff, right, if you had, let's say, 60% of the beefaroni and only 40% of the Gatorade, then your MRS would be different from Wilma's MRS, right? You would value beefaroni less and Gatorade more than Wilma would. As long as you've got exactly equal ratios, that means that Wilma has exactly equal ratios, and both of you value each of these goods the same amount. This makes sense? This is basically what we're going to say about what ought to occur when we're in a when we're in an endowment economy. Right? This is as much as we can say without taking sides between you and Wilma about what a good outcome looks like. So in the next video, we're going to compare this outcome, right, this theoretical outcome without thinking at all about what actually occurs, to the outcome that would have occurred if you and Wilma had met in a competitive market equilibrium. Right? In other words, if you both brought your stuff to some giant emporium where there's thousands of you and thousands of her, and bought and sold until market prices emerged.